So guys, next we will going to discuss L3 route lookup. Now what is L3 route lookup and why do we need L3 route lookup? So whenever a router receives a packet, it has to decide whether the router has to forward the packet further to the next hop router or it has to consume the packet. That is, the packet was destined to the router or the packet was destined to one of the machines which is present in the directly connected subnet of this router. Or the third case is that the router can discard the packet. So how does the router decide that whether it has to forward the packet, consume the packet or discard the packet? For that purpose, the router has to do route lookup. What is route lookup? Route lookup means looking into the routing table and know what to do with the packet. Now to look into the routing table, the router has to provide input to the routing table. The input is the destination IP address which is present in the packet the router has received. So the destination IP address is the key of looking up into the routing table. So it is a key. And when the router looks up into the routing table, the routing table gives the output to the router. The output comprises of subnet IP, that is, what is the subnet IP address in which this destination machine to which the packet is being sent is present. So this is the destination subnet. And the next hop info, that is, what is the outgoing interface of the router, this interface, and what is the gateway IP. This is the next hop info. So the input to the routing table is the destination IP address which is specified in the IP header of the packet received by the router, and the output of looking up into the routing table is the destination IP subnet, is the destination subnet, as well as the next hop information. So let us take an example. Here we show a sample routing table, and let us say that the destination IP addresses is the following three IP addresses. So let's say that the router has received the packet with the destination IP address is equal to 122.1.1.15. Right? So what are the four steps? The router performs these four steps to look up into the routing table. So the router will scan the entries in the routing table one by one. It will pick up the entry 1 and it will apply the mask of the entry to the input IP address, which is a key. Now if you apply this mask to the key, you will get 122.1.1.0. Check the result. So this is the result. Check the result of step 1 and whether it is equal to dest field. So the dest field is this. So our result actually matches with the dest field. Right? So it means that the entry 1 matches and we get the output as destination subnet, outgoing interface, and the gateway IP. If two or more matching entries are found, one with the higher subnet mask is chosen. Now you can see that this entry also matches with the destination IP address which we have been using as a key. You can check that, apply the same steps, apply the subnet mask of this entry to the IP address 122.1.1.15 and you will get 122.1.0.0 as a result, and this result is equal to destination field. So the entry 1 and the entry 4 matches with our key. What is our key? Our key is 122.1.1.15. Now, because there are multiple entries which are matching with a key, the entry with the longer mask is chosen. So for the entry 1, the mask value is 24, and for the entry 4, the mask value is 16. So which one is chosen? The entry 1 is chosen. So breaking the tie between matching entries of a routing table is called longest prefix match. LPM, longest prefix match. So this is how router does route lookup. So note the steps of the route lookup. Whatever be the subnet mask of an entry, apply that mask to the input key and check whether the result is equal to the destination subnet. Right? If the result is equal to the destination subnet, it means that entry matches, and the router uses the gateway and the outgoing interface of the matching entry. So this is how route lookup happens. We will revisit route lookup once again in our later module. Now, we have already discussed that the first entry in a routing table matches when the input to the routing table is the IP address 122.1.1.15. So let us say that the router which is doing this lookup is a router A. So by doing this lookup, router A would know that the outgoing interface is Ethernet 2. And the next hop or the gateway IP address is 100.168.4.1. Now, router has to forward the packet. To forward the packet, any machine or router needs four types of information. The four types of information is destination MAC, source MAC, and destination IP address and source IP address. Now, source IP address in the packet is irrelevant here. So we have assumed that the source IP address in the packet is 1234, and the destination IP address in the packet was 122.1.1.15. So remember, during L3 routing, the source IP address and destination IP address never changes. So source IP address and destination IP address never changes. What changes is the source MAC and destination MAC. When the router forwards the packet to the next hop, the source MAC and destination MAC changes. So remember, source MAC and destination MAC changes hop by hop. Now, where from the router will get the source MAC and destination MAC? Source MAC is the MAC address of the interface which the router A will send out the packet. Now, from the routing table entry, router A knows that the packet needs to be sent out of the interface Ethernet 2. So the MAC address of the interface Ethernet 2 is MA. So source MAC address will be MA. How router A will know the destination MAC address? So destination MAC address is the MAC address of the next hop. Now router A knows that the next hop IP address is 100.168.4.1. Now for this IP address, the router needs to know the MAC address. So remember, router A knows the IP address and it needs to know the MAC address which is mapped to this IP address. So router A launches our broadcast request on the outgoing interface. And in this R broadcast request, the router A asks that, hey, what is the MAC address for IP address 100.168.4.1? Of course, this R broadcast request will be received by the router B. And router B will reply with the ARP reply saying that, hey, the MAC address for the IP address 100.168.4.1 is MB. So router A now knows that the MAC address of the next hop is MB. Now router A knows all the four types of information. Router A can now forward the packet to router B. So this is how route lookup happens, and L3 route lookup is followed L3 route lookup is followed by ROUTE lookup. So in this example, we have assumed that the router A did not have the MAC address correspond to 100.168.4.1 IP address, and therefore it launches the ARP broadcast request. If there was entry in the ARP cache of router A regarding the mapping 100.168.4.1 and the MAC address of this IP address, which is MB, then router A would have simply picked up the MAC address MB from its ARP table and populates the destination MAC address of the packet. So this is how L3 route lookup happens. So next we should discuss the format of the IP header. So IP header again is an important that you should know what are the various fields of the IP header. We will going to discuss only the fields which are of interest of this course, but you should consult your standard book Horizon and you should know regarding rest of the fields of the IP header. So in this IP header, you can see that the source IP address is there and the destination IP address is there. Both fields are 4-byte fields, right? And you have a protocol field here. The value of this protocol field will be the identifier of the next protocol that is running above the network layer. It could be UDP, it could be TCP or anything. We will discuss this protocol field in detail later. Then this identification field and flags and offset, these are all related to fragmentation. Again, fragmentation is a very important concept to know. I may not discuss the fragmentation as a part of this course. You should consult your standard books, again Horizon, and you should know how fragmentation happens and why it happens. Again, fragmentation is important. I may not cover fragmentation as a part of this course, but you should study it from your standard books. So that's what IP header is. So the things to note here is that it has source IP address and destination IP address and the protocol field here. So whenever a router forwards the packet which it has received from the previous router, the router has a time to the router decrements the time to live field in the IP header. So whenever a router forwards the packet, and suppose the time to live field was 63, the router will decrement it to 62 before forwarding the packet to the next hop. So time to live field is useful whenever there is a loop in the network, and whenever a router receives a packet with time to live field equal to 0, the router simply discards the packet. It do not forward the packet any further. So we have taken a look at the IP header. Now, let us take an example of L3 routing in 4-node topology.